Now, this is the trace of the hypothesis that we created. So you can see that from here, uh, we have the null hypothesis, right? And in our example, we use S1. In this one is H1. So this one is the hypothesis that you get the values from X1, right? That is a positive one. And then in H2, we change the normal into don't care. So it can cover both X1 and X2, right? And for H3, we don't change it because the example 3 is the negative one. And the last one, H4, we change a little bit here, warm and same, change it to be don't care, so it can cover cool and change. So guys, what I want you to do to know is we start with the most specific one, and then we change it into H1 that is more general. So you can see that for H0 or HO, this hypothesis cannot cover any data, right? So in H1, it can cover just only X1. When we change it to H2 here, H2 can cover both X1 and X2. Okay, so then H3, that is same as H2, right? It would cover X3. We will have the proof later that how can we think that why we focus on just only the positive one, not the negative, and the negative can be guaranteed that it will be not covered by the H or the S, the most specific hypothesis that we can maintain. Okay, so in the last one, when you change these last two attributes into don't care, it it will be more general, so it can cover more examples like this. So you can see that the the space or the number of the examples will be covered by some hypothesis when it become more general. When it become more general like this, it will be larger. It can cover larger areas. Okay, so in in this example is the way that we change the hypothesis from the most specific one to be more and more general. Okay, guys, so now it's time for us to check that why it or why the most specific hypothesis that we try to maintain it won't cover the negative example. Of course, the negative example here is look at this. It is rain, cold, high, strong, warm, change. It How can we guarantee that it is the most specific hypothesis here that we try to maintain will not cover the negative? I'll tell you. This one is another word called bias. Okay, the bias is a constraint or conditions that we added. Okay, the conditions that added. Okay, by us, by the one who try to train the model. So I'd like to change it a little bit, change the position a little bit here. Sorry. Okay, we try to add it. The hypothesis is the added conditions that, oh, sorry, the added conditions that try to make the learning algorithm to be able to learn. So the bias that we add to the find S algorithm here is the find S1 is we 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 think that we think that if this representation if this representation contains an answer, we can find it or we can find them if there are more than one answer. If there are more than one answer, that can cover only the positive example, not the negative one. So find S algorithm can find it. So guys, the key is here, if this representation contains an answer, it means that this representation is our 6 slots. If we can put some values and it can cover just only the positive. If this representation has an answer, so it can cover it can be found. So this is the condition that we add to this situation. Okay, so maybe you think that, okay, maybe it has some situation. Of course, this situation is very easy. That okay, so example here, the third example will not be covered for sure because change, we change, we like to make it like more general, more general. That is the very smallest step that we make, right? So guys, the idea is we try to maintain it from we try to maintain it from the most specific one, right? And try to make it more general, more general, and more general. So we try to make it like this one is not cover anything, and try to make it more general and more general, right? So the way that we did is we try to enlarge the area, okay? Like using the smallest step that can cover the area, that can cover more examples. So we can think that it is, if there is an answer, it it is the like the smallest step, so it won't cover the negative one for sure. If there is an answer, if if the answer is like, if you cannot find, if you cannot use this representation to find the answer, of course, if this representation cannot be used to represent the answer, of course this is not in our scope here. In the next clip I'll show you what what did I mean. What did I mean? Do we have any other example that like cannot be represented using this representation? See you guys in the next clip.